So now we are going to start discussing some basic type of pumps uh, and their operation and different types so that you can get familiarized with those pumps. So the first type of pump which we are going to discuss that are centrifugal pumps. So let me share the. Now we are going to discuss the centrifugal pump and their its operation, how it operates, and then different types. So, if I can show you the picture of the pump, maybe you can readily understand that what I am talking about. So, this is kind of a picture of centrifugal pump. And there are certain things you can see here. One is the this is motor which derives the shaft. Shaft is somewhere here inside this, which is connected with the impeller, which is here, impeller I, and then here we have got impeller blade. I could show you the schematic in a while, but just to tell you the operation when we switch on the motor, this is inlet inlet for the which is connected with the with the storage tank, which is on the ground level, and then the water comes from here. It goes here inside this, and then it comes into uh, this casing, and this casing we usually call it roll, or we also call it volume. So it comes into casing, and then water comes accurately in this direction, and then inside this casing, we have got impeller and we have got blade. So then it moves in the radial direction, and then it goes like this. It take a circular motion, and then it comes out of this. This is the outlet, and then this outlet we have got a pipe here which takes it to the overhead tank. Right? This is inlet, this is outlet, this motor, and this is here, this is the shaft. And inside this spool, we have got impeller blades. Let me show you the schematic as well now, just to make things a little bit more clear. So, just a minute. Okay, so here you can see some similarity. So if we see it from the front, and reverse like it is the reverse of this. If we kind of see from the negative y-axis, it is kind of the same thing, right? And then if we see it from the from here, from this side view, if we see it from here, that is the front view, and then this is the side view. So side view is shown here, I think. Right? So this is the side view. So here that is the this is the shaft, and then it is coming in axially, and then it is going in the radial direction. And the impeller blade, which is inside this volume, that are shown here. Right? These are the so it means that this is the shaft or the impeller eye. So it is rotating, and the flow comes like flow comes here, and then it actually it comes out of the board, and then it goes like this, right? So first it comes axially in this direction, which is in the side view. For the front view, it means that it is coming out of the board. And then when it comes out of the board, and then because the blades are rotating, it imparts the rotational kinetic energy into the blade, and then in the process, the velocity and pressure increases. Right. So this is the basic working principle of this. And then second thing, if you realize here that if I show here this thickness and this thickness, here it is kind of increasing the thickness as the fluid goes towards the outlet. So it means that we know that when we say that if I kind of take it out and show it in a simplistic way, so we are talking about a shape, diffuser shape. So here it is minimum at point A, and at point B it is maximum. So A and B. So we know that what is the characteristic of diffuser? That is that it increases pressure at the cost of decreasing velocity. Right? So it means that a dynamic head is changed into static head, and usually in case of pumps, we need some very high pressure at the outlet of the pump so that the fluid can travel against the gravity towards its destination, whether that is somewhere, whether that is the overhead tank or any other application. So for that purpose, we use higher pressure at the outlet, which is so at this point, if I write it, high pressure, low velocity. But here at point A, high velocity and a little bit of lower pressure as compared to this at point B, right? As compared to at point P. So this is the purpose of increasing the shroud area so that it can have more kind of which is shown here. I know this thing it has got more outlet area. Inlet area is less, outlet area is more. So pressure increases at the expense of velocity. So this kinetic energy is a result of that velocity in the radial direction and due to the centrifugal force. So the flow leaves the impeller after gaining both speed and pressure. But a little bit of speed is reduced as it moves toward the outlet so that we can have high pressure at the outlet, right? So this is a snail shaped case. So we can recognize the centrifugal pump very easily. So usually the major purpose is to increase the pressure head at the outlet, not necessarily the velocity head. Because if the even the velocity is lower, then if the pressure even in that case the flow would move towards uh, overhead type if the pressure head is there. Right now, in case of this uh, centrifugal pump, we have got three arrangements of centrifugal pump based on the angle of this impeller blade. So, what are these three types of the centrifugal pump? Let me explain it here. One is called backward inclined blades. Backward inclined blades. So, first centrifugal pump would have backward. What does it mean backward? Because the flow is moving in this direction. So if we take it forward direction, right, if where the flow is moving, if you see the angle of the blade, it is in reverse direction, right? In this, let's suppose this clockwise direction is forward direction. So these are kind of giving the flow uh, uh, anti-clockwise kind of direction. So That kind of blades are called backward inclined blades. And what are the major characteristics of backward inclined blades? It gives us it gives us maximum efficiency for the three arrangements, and then the pressure rise is intermediate, maximum efficiency, pressure rise is intermediate, and then we will see the operating range is also limited. So this, I would explain this third point maybe when we discuss the characteristic curves in a while, right? So now that was the backward inclined blades. Then the second type of blades, they are called, we call it radial blades. So what are radial blades? Let me show you the difference between centrifugal, this backward blade and radial blade. Let me show you. Okay. So okay, so here you can see that figure A is backward inclined blade, because if the fluid is going in the forward clockwise direction, this angle of the blade, it is trying to give the fluid a backward anti-clockwise, right? And then this is a radial blade, so there is no angle which is imparted by the fluid blade. So it is kind of the kind of straight blade arrangement. So we call it radial blade, radial blade, impeller, radial blade, impeller or impeller, right? So usually, what are the characteristics of this? That the net pressure rise is the largest in this case, is largest, but efficiency decreases rapidly, rapidly after the BEP. What is BEP? BEP is the best efficiency point. Is the maximum efficiency point after the BP, that efficiency decreases very rapidly, and also the pressure rise decreases very rapidly. So we will see it in a while once we show the characteristic of for these three blades. So it means that the volume flow rate uh, volume flow rate uh, range is also limited. Right. And and these were the second type of centrifugal works. Number three is we call it forward inclined inclined. So let me show you the diagram for that. Now I'm going to show all three diagrams uh, side by side just to make things a little more clear. So back there. So figure A is for the backward inclined plates, figure B is for the radial plates, and figure C is for the forward inclined. So these are the forward inclined blades. Now there are certain differences between these three blades which you can readily see in case of forward blade. One is it has got very a large number of blades as compared to the radial one and centrifugal one, backward angle blades, right? Second thing you can see that the impeller diameter or impeller eye it is quite big. This circle is you see this circle here it is very big kind of. Here it is kind of quite small in both these cases. So what is the consequence of this? That the blade length is quite small in this case, right? So it can accommodate more volume flow rate, or maybe it can be used for a larger range of volume flow rate applications. So usually we install forward inclined plate when we require a constant pressure, which is there for a larger range of volume flow rate. So let me write it. Applicable for application involving a wide range of volume flow rate. Right? So it has got the wide range application. So the in case of forward inclined plane, right? So, but it has got the pressure head. It is minimum. The pressure head rise is is I think minimum. Pressure head rise across blade minimum. How do we know that? Let me show you the characteristic curves for the three arrangement. Here you can see the curves which are for the net head for a certain kind of arrangement. So if you can see that the radial one, it gives us the maximum head. But what is the drawback for this? That after this point, the net head drops very sharply, right? And it even decreases for the backward one also. But for the backward one, the decrease in head is kind of a little bit gradual, as it is shown by this line. But for this dotted line, you can see that the slope of decrease is very rapid if we increase the volume flow rate beyond this point, right? But for the forward one, you can see that it maintains a very acceptable pressure head even for a larger volume flow rate. So it means that if we want to use a pump which is can be used for a wider range of what do you call it, wider range of volume flow rate, then we would prefer forward differential, forward inclined blade. But if we want to have a pump which is being operated in a very small range, like this up till this point, maybe for the smaller volume flow rate, then the backward one is the best one. Why is that? Because it gives us the maximum efficiency, right? So backward usually for uh, for a small volume flow rate, it would give us the efficiency. We are not talking about the head at the moment. We are talking about the efficiency. So this backward inclined impeller would give us the maximum efficiency, right? But if we are talking about head and we have got the lower value of volume flow rate, then radial one is equally good, right? And then you can see BHP values, which are the what is BHP if you remember? BHP is tau into omega, right? Tau is the torque. So for a given rotational speed, so it means that this forward inclined blade would give us the maximum torque, followed by the by the radial one, and then the least one is given by the by the this backward one, because backward, as you can see here, that this backward one here, the flow is going to come like in this direction, right? But actually, it should go out, right? So that is kind of the little bit of loss in BHP due to this reverse motion. But because it would give us the very high pressure head, so that's why we use it. So kind of here is the pressure. You can see that is very good. So usually we can use it. So just to summarize that, if we want to use the a situation or application where we are not sure about the range of the volume flow rate, then we usually use this uh, forward inclined impeller pump. Otherwise, if we want to get the maximum efficiency out of the pumping system, then we would. So let me write it here. If I can summarize it, that if we want wide range of volume flow rate, we will use forward inclined plates, and if we want to have maximum net head at lower volume flow rates, then we would go towards radial radial blades, and then if we want to have maximum efficiency at lower volume flow rates, then we would go towards backward. So what is efficiency, by the way? Efficiency of a pump, if you remember, that is the useful work, useful useful work imparted on the fluid, divided by BHP. So these are the three parameters we usually use for the selection of the inclination of the blade angle, whether there is zero angle, minus angle, or backward angle, or forward angle. So these are the general uh, general selection criteria we usually use, right? So we discussed this, and now we can quickly go through the axial pumps, maybe in 5 minutes, because I just need to show a couple of slides for that. So let me tell you that, maybe it will take much. So, because why I am just telling you the different types and working principles, because now in the next remaining of the classes we will discuss the this hydraulic turbines as well. So we have just seen these characteristics for the centrifugal pump. Now we move on to the next type of pump, which are axial pumps. So what is the difference between centrifugal pump and axial pump? That before we move forward, what is the application of centrifugal pumps? And they are quite widely used. Let me tell you where they are used. They are used in home appliances like dishwashers, washing machines, dryers, water setting pumps, which we usually install in our home, hair dryers, vacuum cleaners, then they are also used in cars, the water pump in the engine, then the air blower used for AC or heating application, then centrifugal pumps are they are also used in industry. They are for the building ventilation system, washing operations, cooling phones and cooling towers. So they have got various applications. Right. So now we discuss briefly about the axial pumps. So axial pumps, what is the basic example of axial pumps? That is the ceiling fan. We usually install in our home. They are kind of axial pumps, right? Or we call it not we call it fan. Because we are not concerned about the increase in pressure, but we are more concerned about the increase in volume flow rate, which is going to be striking our body just for the sake of therapeutic cooling to give us some comfort level in summer, right? And the second example of axial pumps or axial fans or propeller, they are the blade of helicopter, right? So it means what is the difference between axial pumps and or fans or and centrifugal pumps? The direction of flow remains almost perpendicular to the rotation, right? So flow would come in this direction for the if we see the this helicopter, the flow would be coming from the top to bottom and then go down because now the high pressure region would be created on the down region, so there would be a lift created in the upward direction, right? So the lift force on the blade is caused by the pressure difference between the top and bottom surfaces of the blade, and the change in flow direction leads to downward uh, downwash a column of descending air through the rotor blade. Okay, so this kind of lift generation we also discussed in chapter number 9 when we said that there would be a high pressure region on the lower side and the lower pressure region on the upper side, so that the left and that vertical force would be there, which is the lift force. Another example of that is the propeller of like this horizontal propeller. The rotor rotates in vertical plane. Here it is rotating in horizontal plane. So that was the blade of this. But there are also some blades on here which rotate in the vertical plane. So that is called propeller. So we have got ship propeller as well as aircraft propellers. Like C-130, we have got some propeller in that. So both the helicopter rotor and the airplane propeller, they are example of open axial flow fans. Since there is no depth, so it means that there is no body which is kind of bounding that flow. So they are open flow, like a ceiling fan. There is no kind of casing. But in centrifugal pumps, there was a casing. If you remember, that is the casing. If I can show you. This is the casing. So that is kind of closed body pump. But this is open flow pumps are fans. So ceiling fan is also the same. Then there is a pump which is installed in your laptop or in your desktop. That is also kind of this thing. So this is also kind of a example of ducted axial flow fan. So usually we use the axial pumps in stages. So it means that the pressure rise across one stage of the axial pump is lower. So that's why we put stator, rotor, stator, rotor. Like in thermodynamics, you must have studied the multi-stage pump or turbine. So usually we use axial pump or turbine arrangement in a multi-stage arrangement in which we have got a stage of stator blades and rotor blades. Then afterwards we have got again stator, rotor. So in practical application, maybe we can have more than 100 stages when we talk about an axial compressor or axial turbine when we are talking about nuclear power plants or things like that, or a big gas power plant in which we need to compress to a very high pressure ratio. Then we cannot achieve that pressure ratio in a single blade, in a single stage of the stator and rotor arrangement. So that's why we kind of put like hundred of stages. Maybe I can show you those stages in the beginning of a figure which I shown in the episode. Yeah. Can you see this figure which is on the left hand side on the bottom? Uh, bottom figure on the left hand side, you can see multiple stages of the blades. So this is the actual compressor or turbine which is installed for a nuclear power plant or a gas power plant. Right? So it is kind of, you can now you can see that multiple stages here. But in centrifugal pump there is no multiple stages. There is only one kind of thing. Right? So the last thing which I need to mention here is that is the characteristic curve. So here you can see that the quantitative performance curve for a typical propeller fan. And now you can see that the BHP decreases with increasing volume flow rate. Right? So it means that the brake horsepower which is going to be provided that would decrease with the increase in volume flow rate, and then efficiency that also decreases rapidly after the best self point, and health is also kind of decreasing more and more while it remains constant for the centrifugal case. Here, this you can see that it decreases after having a lot of states lying here, but in case of axial fans or pumps, it decreases rapidly at hand. Right? So the brake horsepower tends to decrease with flow rate. The efficiency of propeller drops off rapidly for volume flow rate higher than that at the best efficiency point. So best efficiency point is this point where we have got maximum efficiency. And that has also decreases continuously with the flow rate. So just to give you an idea, so now that is the comparison between a centrifugal pump and exit pump. So usually, if we are talking about broadly speaking, and we are talking about an arrangement where we have got compressor. So usually we don't use centrifugal pump for that. We usually use axial compressor. Usually, right? So that was it for today's lecture. So from the next class, we are going to discuss the turbines, and in that we would discuss different classifications, impulse turbines, reaction turbines, and then at the end of this course, we will discuss the hydroelectric dams like the Villa Dam, Mangla Dam. It is necessary that you know that what is the working system. So hopefully we would be able to cover it in 4 hours of time. So hopefully you would have a better understanding of technology by the end of this course. But again, as I said, that it is just a tip of the iceberg. So you can, I hope, get more knowledge as